Hello students, welcome back to OrganiChemVerse. Today I'm back with some more JEE Main 2026 session 1 questions. The first question is from the basic concepts of organic chemistry, wherein you should know the UPAC nomenclature of the molecules and what type of isomerism do they exhibit. So you're supposed to match the pair of the compounds from list 1 with the type of isomerism they exhibit from list 2 and then choose the correct answer from the given options. So let's start writing the structures of the molecule. The first one is 2-methyl propene. So this is propene and this is 2-methyl propene. And the structure of but1ene is this. So these are bond line structures. It's always better to write the bond line structures because it's quite simple and you can save some time as well. Now, what is the relationship between these two molecules? The number of carbons in the longest chain itself is different. Therefore, they exhibit the chain isomerism. They have the same molecular formula, but the number of carbons in the longest chain is different. Therefore, A is nothing but 3. So we'll write that here. Now, let's see for B. Cis-2-butene. So this is cis-2-butene because the hydrogens are on the same side of the double bond. And trans-2-butene is this. So that means what? They have the same number of carbons, but the orientation of the atoms or the groups, it is different. So what type of isomerism do they exhibit? They are geometrical isomers, but we don't have any geometrical isomers here, but we do know that geometrical isomers are type of stereoisomers. So B will match with 1. So B will match with 1. Just check from the options. If you are lucky enough, there will be only one such option wherein A is 3 and B is 1. But here we have two options. So let's eliminate one of the options. So for that, you check for C. 2-butanol. This is an alcohol and then diethyl ether. The number of carbons, hydrogens and oxygen is same. That means they have the same molecular formula, but the functional group is different. Therefore, they are functional isomers. That means C is 4. So C is 4. There is only one such option. Therefore, the right option is as shown in option 1. Let's verify for fourth. That is D. But1ene and but2ene. So they have the same molecular formula. Number of carbons in the principal chain is also same, but the position of the functional group is different. Therefore, they are, what is left over here? D is, they are positional isomers. So the reason being the position of the functional group is different. The next question involves series of reactions for nitrobenzene molecule. Then we need to write what is the major product P and then find out how many bromine atoms are there in the final product P. Whenever the series of reactions are given, it's always better to write down the reactions. You don't have to write the reagents. You just write like this. So when nitrobenzene is treated with bromine FeBr3 and heating condition, it is nothing but a bromination reaction. And where the bromine should go? On the meta position. Why so? Because we know that nitro is an electron withdrawing group. Whenever there is a minus R group, it's an electron withdrawing group. So because it's electron withdrawing, it's a meta directing group. That means the group will go to the meta position only. So in many cases, students will not know whether they have to do the monobromination, dibromo or tribromo. I'll give you a simple trick here. If the group is electron withdrawing, so it is deactivating the benzene ring. Because it's deactivating, the electrophile bromine will attack only once. Therefore, you are going to get only one bromine on the benzene ring. Now, the second reaction condition is reduction. Tin HCl heating condition means reduction because there is a nitro group. So you are removing oxygens and adding the hydrogen. So that's why we call this as reduction. And you are going to get metabromoaniline. But since there is a acidic condition, what happens is this aniline is a base. Therefore, it's going to react with the acid present here. In the reaction mixture, you will have anilinium ion. So it's a simple acid-base reaction to form an anilinium ion. So for that, what we do is we always do the pH neutralization. Therefore, you are going to get NH2 like this. And this is a metabromoaniline. Is this step really important? Yes, it is really important. Why so? Because when we do the next reaction, that is bromine in water, so the product depends on whether it is anilinium ion or aniline. That's why we have to neutralize the reaction here so that this will be in the form of aniline only. So what exactly it means is when you treat this with bromine under water condition, this will form bromonium ion, which is an electrophile, and this will attack the benzene ring. Again, simple electrophilic substitution reaction. Here we have electron withdrawing group, whereas NH2 is a electron donating group. Electron donating groups are orthopara directing groups, and they always activate the benzene ring. So there are two reasons here. NH2 is activating benzene ring, and we have many bromonium ion because it is taken in water, right? So because of more number of electrophiles and because of the electron donating group, both the ortho positions and the para positions are going to be substituted by the bromine now. So how do you write the product here? Just observe carefully. So NH2 is a orthopara directing due to more number of bromonium ions. All the three positions will be occupied and the bromine from the previous molecule must be retained. Now, let's see the next step, that is diazotization. The moment you see this reaction condition, NaNO2 HBr 0 to 5 degrees Celsius, either HBr or HCl. So what happens is we are going to form a diazonium salt. If you already are familiar with these reaction conditions, you can reduce the number of steps and you can write in one step itself. So you can see that there are already 4 bromines substituted, right? And again, what do we do here? CuBr, NaBr. Is going to replace the N2Br by Br. So this is a Sandmeyer's reaction. It's a named reaction. So this is a Sandmeyer's reaction to form a pentabromobenzene. So therefore, how many bromines are there on the benzene? There are 5 of them. Hence, the final product P contains 5 bromine. The right option is option 3. The next question is from Basic Concepts of Organic Chemistry class 11 chapter. You should not miss out any marks from this particular topic. It's quite easy. You just have to substitute the values given in the equation I have written here and then you will get the right answer. The question is, by usual analysis, 1 gram of compound, that is organic compound, gives 1.79 gram of magnesium pyrophosphate. The percentage of phosphorus in compound is, so always choose the nearest integer. The given molar mass of oxygen, magnesium and phosphorus are here. You don't have to use this data if you remember this particular formula from the Carey's method of estimation of phosphorus from the organic compound. So let's calculate. So the percentage of phosphorus is equal to 62 divided by 222. Substitute the values. What is the mass of the magnesium pyrophosphate? That is 1.79. What is the mass of the organic compound? 1 multiplied by 100. So then simplify for this, you are going to get the value as 49.9, but which is the closest value? The closest value is 50. Therefore, the right option is option 1. In this question, we have to match the reagents given in list 1 with the name of the reaction given in list 2 and choose the correct answer from the given options. It's easy to match the name of the reaction with the reagent. I always remember like this. In Itard's reaction, we use chromyl chloride to convert cetol into benzaldehyde. Therefore, so 1 matches with C. Next, Rosenmund reduction. It is the conversion of acid chloride to aldehyde using a reducing agent like hydrogen, palladium, barium sulfate. So 2 matches with A. And then the Gattermann-Koch reaction is a reaction of benzene wherein it is converted to benzaldehyde using carbon monoxide, HCl, anhydrous aluminum chloride. So third matches with D. What is left over here? Stephan reaction. And Stephan reaction is used to convert cyanobenzene to benzaldehyde. So 4 should match with B. Therefore, A is 2, B matches with 4, and C matches with 1, and D matches with 3. And where do we have it? We have it in option 4. Therefore, the right option is 4. The next question is from haloalkanes and haloarenes. You have to arrange the order of reactivity of the given benzyl halide compounds towards potassium cyanide. First, let's see what is the reaction of benzyl halide, that is benzyl bromide, towards potassium cyanide. Here it will undergo simple nucleophilic substitution reaction. So what is the nucleophile here? Cyanide. It will substitute the bromide ion. So bromide is a very good living group. So you are going to get a cyanide over here. Don't forget that there is one more carbon here. Okay. So you are going to get a product like this. Now, what type of reaction is this? As I told earlier, it's a nucleophilic substitution reaction, but is it SN1 or SN2? Generally, the primary halides will undergo SN2, but in this case, although this is primary halide, it will undergo SN1 reaction because in SN1 reaction, the formed reaction intermediate is a carbocation, and this carbocation is stabilized by the benzene ring. The benzene ring donates the pi electrons and stabilizes the carbocation. Hence, it will undergo SN1 reaction. So what is the order of reactivity of these benzyl halides? It depends on the group present on the benzene ring. If this is attached to electron donating group, it stabilizes the carbocation, hence the order of reactivity will be more. If it is attached to electron withdrawing group, then it destabilizes the carbocation, therefore the order of reactivity will be less. Look at the groups present here. The OH and NH2 both are electron donating group because of the positive resonance effect. They donate the lone pair of electrons present on them and stabilizes the carbocation. Whereas nitro is an electron withdrawing group. Therefore, it destabilizes. So wherever we have C and D, it will be the least reactivity. I think there is some typographical error, so you can ignore the fourth option. Now, between A and B, how to choose which is more reactive? It's something to do with the negative I effect, electron withdrawing nature of oxygen and nitrogen. Oxygen is more electronegative, therefore it destabilizes a carbocation. However, it exhibits plus A, there is slightly minus I effect. So, whereas nitrogen is less electronegative than oxygen, so it can donate electrons easily. Therefore, NH2 is a better group. And you have such two options. So, B is greater than A, B is greater than A. But how to choose between C and D? Between C and D, you have to look at the position of the nitro group. Whenever there is an electron withdrawing group at ortho and para position, since it will undergo resonance directly like this, its effect will be more and more. If it is at meta position, it will not exhibit the minus R. It will exhibit only minus I. So therefore, The nitro, when it is at para position, it withdraws more electron, making it least stable. Therefore, C is the least reactive, you can say, right? So therefore, the right option is option 2. Thank you for watching this video. The rest of the questions I am going to solve in the next video.